Hey, I'm Charlie May. I am a sophomore.
Hi, I'm Javan Pandya, and I'm a freshman.
So what we're going to be presenting is a robot. This is our challenge robot that we use on our robotics team. We helped design it, build it, and create some code for it, and we're going to be showing you some close-ups of the robot right now.
We faced many challenges while programming and building the robot, but eventually it all paid off in the end.
And so there's basically a bucket, intake system right here on the front of the robot. There's in the middle of it, there's a bucket that where the items will go, and then a shaft lifting it up the bucket to place it in the right level. And then on the sides, we ended up designing our team number and different things. On one side, we have 4100, our team number. We're the Tigers, so a tiger claw is in the symbol of tiger. And on the other side, we just have COVID, because COVID has affected us and our team a lot.
Alright, so the tele-op of the code allows us to use this controller, well, multiple other controllers, and move the robot just one press of a button. And as you can see here, they could lift the slide, empty out the blocks in the bucket, or spin the servo up here. And we need two controllers, one that operates all the small mechanics up here, and one that actually drives the robot, as you can see right here. And the other part of coding the robot is the autonomous, which this is what the robot runs to just do automatically, no pushes of any buttons. And as you can see here, we're about to run some programs of the autonomous, and in a few moments you'll see it right now.
So as you can see, we selected Blue Duck Storage. It's one of 3 autonomouses on the blue side that we can run, and with it, it reads there's one of 3 possibilities that can happen. There's a lace cup that decides what level of the shared alliance hub that will lay on. The middle is the middle, the right is the top, the left is the bottom. So with it, it will read where the lace cup is, then it will go spin the ducks off, and then after it spins the ducks off, it will go and deposit the cube in whatever layer it was designated. Then after, it will go and park in the storage.
So here is the code for autonomous. So first we have the startup for the vision of the robot, the camera, which it detects the duck, our marker scoring element, as duck. And then first, to start it, once you press initialize on the driver hub, the bucket on the robot will be set to a very level height so the block doesn't fall off. And then once the robot initializes and sees that the duck, or our scoring element, is in either the left or middle or right position, it understands that in one of these each mean a different point on our scoring goal. So first, it will follow the trajectory to the duck carousel. After that, it will rotate it and set the motors so then the duck will fall off. Next, it will prepare itself to activate the bucket, and so after it has, it will raise up to the position that was identified earlier with the scoring element. The bucket will slam down, releasing our box, and then after that, it will finish by closing everything back to its starting position, and finally it will go back to the parking spot, the designated area, and then it will end the autonomous.
So overall, this was a really fun project for all of us. We ended up loving doing this robot together, and we ended up having a community around us that helped. We have other students in our school that helped design the robot, and it was really fun working together as a group. If one of the skills that I learned myself was the capability of thinking out a process and making sure, for example, we didn't just build this from we ended up planning an idea out, getting designs, thinking of what would be the best thing for the robot. And one thing, for example, is we weren't even sure about what the wheels we were going to use. We were thinking about having a 6-wheeled robot that moved like a tank. And just the thought process and thinking that way was a lot better. The thing I would change for improvements would be we have had very unlikely, but before there's been a duck falling off the carousel, lands perfectly under our robot and messes it up when the wheels are turning. That's the only thing I think we could really improve on it, but besides that, it is really just something that we all work together and spend really fun doing. And what about you, Calvin? What have you learned, and what would you try to do to improve this?
What I have learned so far from playing around with this little robot, working together as a team, it was a great experience. We all had great ideas, we all collaborated, and we got everyone to have their say in what they thought was best for the robot and team. One thing that I think we would do different or improve would be, I guess, to just prepare for anything, because like Charlie said, that duck, just that one run where the duck fell into the wheels, and that just screwed the entire thing up. If that happened in a competition, then I think it would have played out extremely worse.
Yeah.
So I guess just always be prepared and take your time, of course, working together with this robot, because there isn't always going to be a perfect way to accomplish your goals with this.
We've been fortunate enough to never have any horrible mess-ups in competition with our code. We have had it happen beforehand, but every time we've been able to capitalize and be flexible enough to be able to cooperate with the other team. And besides that, this robot's been a lot of fun to work on. What makes it different from other robots is it almost has no weakness with it. It is thin enough to go in there's a railings on the field that I'll show you right now, just a short clip of it. These railings are something that not all robots are able to drive over, but we are able to drive over. But then also there's a gap to the side, which we're able to drive to the side. So no matter what, you have an ally team that works with you, we're able to work with them no matter the situation. And then one thing is, that's one thing that sets us apart. A lot of teams cannot cooperate with the other team, but with us, we are flexible enough for any team. That is one thing that makes this robot different. Also, this is our competition robot. We use this for meets and stuff, and so we've been able to participate really well and do well in these tournaments because this robot just has all the capabilities that not every other team has. I'm sorry to tag this on at the end, but right now we are showing you a game, and we are 4-1-0-0, and we scored 234, which is one of the highest games scored in the state. And hope you enjoy.